Okay, and then the final part of Surds is something known as rationalising the denominator. Now, what we mean by that is surds are essentially irrational numbers. You cannot write them as fractions. That's the definition of an irrational number. Rational numbers you can always write as fractions, irrational ones you cannot. So let's start with this first question here. We are being asked to rationalise each of the denominators in very simple terms, because I know that sounds complex, but in very simple terms, all that means is get the surd off the denominator. The reason why you might want to do that in real life is very simple. Think about what a fraction means. It means division. So when you've got something like a 2 in your denominator, it means that you're splitting something into 2 equal parts. Or when you've got a 3 in your denominator, you're splitting it into 3 equal parts. But having a root 3 in your denominator doesn't really make sense in real life. How can you split something into root 3 equal parts? It just doesn't really work. So that's why in real life we like to rationalise our denominators. Very simple way to do it. If you've just got a single surd in your denominator, like on this first one, all that you need to do is times the top and bottom by the surd. The reason that you times the top and the bottom by it is just basic fraction rules. Of course, whatever you do to the numerator, you do to the denominator, and vice versa. Otherwise, you're changing the size of the fraction. So on this first one, we're going to take our fraction, and we're not going to change the size of it. I'm going to times the top and the bottom by the same thing. Root 3 over root 3 is like timesing by 1. So we're definitely not changing the size of the original fraction, but we're just going to change how it looks. So on the top, we're going to get this 5 times root 3 when we times those numerators together. In the denominator, root 3 times root 3, laws of surds again, combine them into 1, you're going to get a root 9. Looks like we've still got a surd in the denominator, but look carefully though. Root 9 can actually be square rooted. So leave your numerator. We don't mind having a surd in there. It's the denominator we don't like. Root 9 though, we can simplify to 3. And then you've done it. You've taken the irrational bit out of the denominator. Yes, it's moved up to the numerator, but that's absolutely fine. We're splitting that numerator into 3 equal parts, which makes sense. Same idea on the next one. We are going to take our fraction and we're going to try and rationalise the denominator. A couple ways you can do it actually. You could times top and bottom by 2 root 5, so just by the whole denominator, but actually you can just times it by the surd that you have in the denominator, so just the root 5. And again, it's like timesing it by 1. We've got root 5 over root 5, that is 1, so we're not changing the size of the original fraction. We're just rewriting how it looks. 7 times root 5, nice and simple. In the denominator though, those 2 root 5s we combine into 1, and we're going to get a root 25. From there we simplify. Leave the numerator, because it can't be simplified, but that denominator, root 25 is 5, and then we times that by 2 to give us 10. You've rationalised the denominator. The final one that we're going to look at together here is slightly different. You can see that we don't just have a surd in the denominator, we're actually subtracting 2 different terms there. And it's the same idea when you're adding as well. What we're going to do is something quite special here. We're going to times by something known as the conjugate. That sounds really complicated, but it's really simple. The conjugate is simply where you flip the sign in the middle of your 2 terms. So what I mean by that is instead of multiplying by 5 minus root 2, we're going to times by 5 plus root 2. But again, we have to do it on the top and we have to do it on the bottom as well. Then from there, it's similar to expanding brackets actually. I need to multiply the 8 by all of 5 plus root 2. So I need to multiply the 8 by the 5, which is going to give me 40, but I also need to multiply the 8 by the root 2, which is just 8 root 2. Similar with our denominators, put them both in brackets, we're going to times one denominator by the other. You can see it's like expanding double brackets though. Goes back to the same skill as before. 5 times 5, 25. 5 times by root 2, 5 root 2. 5 times minus root 2 is minus 5 root 2. And minus root 2 times positive root 2 going to give us minus root 4. Something special happens here. What we've actually ended up doing with the two denominators, if I just highlight them, we've actually ended up doing a very special form of expanding double brackets. And it's known as difference of two squares. What always happens when you've got that special form of expanding double brackets, these two terms cancel out of each other, which is exactly what we want. We've got positive 5 root 2's, but then we take 5 root 2's away. That leaves us with no root 2's there at all, which is nice. So then what we end up with is the same numerator, 40 plus 8 root 2. And in the denominator, we end up with none of those 5 root 2's, they cancel out. But the root 4 is 2, isn't it? Square root of 4 is just 2. So it's 25 take away 2. That's going to give us 23. And again, we rationalise the denominator. There's no surds there anymore.